to the chemistry lectures by Dr. Anima Upadhyay. And in this video, we will learn about the knocking in the diesel engine. Let us start. The knocking in the diesel engine is explained as the metallic sound produced due to the delayed ignition of the fuel in the engine, which results in the accumulation of the fuel in the engine, and on attaining the ignition temperature, it burns suddenly and explosively, resulting into a large sound, which is called diesel knocking. Let us learn the mechanism in the diesel engine. So in the diesel engine, only the air is drawn first in the cylinder. In the petrol engine, we have seen that air and petrol are drawn together. But in the diesel engine, we only take the air in the cylinder and then compress the air to around 500 psi pressure, which results in the rise of temperature in the cylinder to about 500 degree centigrade. Towards the end of the compression stroke, the fuel is injected in the cylinder in the form of a spray. The drops of the diesel oil absorbs the heat from the hot air and gets ignited on attaining the ignition temperature. As a result of which the vapors are formed and the expansion of vapors takes place, which pushes the piston down, and this is called the power stroke. But this combustion of diesel is not spontaneous. It takes some time to attain the ignition temperature. So there is a delay in ignition, and this delay between the injection of the fuel and ignition is referred as ignition delay. As a result of which, the oil gets accumulated in the engine, and when it attains the ignition temperature, the oil ignites suddenly with an explosion, resulting into a large sound. This is called diesel knocking. The ignition delay is small for paraffinic fuels, that is straight chain fuels. The ignition delay is small, but with branched structures and aromatic compounds present in the diesel, the ignition delay is large. So, if we discuss about the factors that affects the knocking in the diesel engine are the engine design. The nozzle should be like the one with which we can spray the oil uniformly in very small droplets so that they can absorb the heat from the hot air quickly and attain the ignition temperature. That results into the engine design, which is responsible for engine design. The second important thing is the efficiency of mixing of air and the oil spray in the engine. They should mix quickly so that there should not be any delay. And the third important thing is the nature of the fuel used, its structure and molecular weight, which determines knocking. As I have already said many times, that in the diesel fuel, the branched structures and aromatic hydrocarbons should be avoided in the diesel fuel. There are many drawbacks of knocking in the diesel engine also, same as in the petrol engine. It affects adversely and leads to the abrasion of the walls of the cylinder. Consumption of fuel increases drastically. The power density is greatly reduced As a result of diesel knocking, production of loud noise, which is not desirable, leads to noise pollution. Overall performance of the engine is also lowered due to knocking. How we can avoid the knocking? So, the suggested things are, first of all, we should look after the design of the engine and the nozzle with which the fuel is sprayed inside the cylinder. Second important thing is the high cetane rating diesel fuel should be used. Use of anti-knocking agents in the diesel such as ethyl nitrite, ethyl nitrate, isoamyl nitrites, acetone peroxide, if mixed with the diesel as dopes, reduces knocking. So now we have learned the mechanism of knocking in diesel engine as well as in the petrol engine. But again, I'll remind you that diesel is a fossil fuel and on combustion it produces pollution. Thank you.